Hi and welcome. This time around we have to make another rotary fixture like you've never seen one of those before. This is a laser welding fixture for this part right here. Actually, there's 4 more parts that stack on top of this. Here is a 3D view of what the overall part looks like. So there's a lot of rotary welding here, but we need to clock based on this specific position here. Now normally, I've got a piece of material here. My thought would be to make a pocket for this guy to fit in and then something to press on one side. But this time around, we're not doing that. We're actually going to use 3 pins and a really creative eccentric cam to hold it in place. And I 3D printed these parts. Originally I was going to machine them, but 3D printed these parts which will press against this part and the rotary cam will press against this because I didn't want to mar this material because the rotary cam is going to slide in. And a lot of these vendors do not want their parts scratched up. So this part will sit on top of it. And then the rotary cam will push against this part, which will push this guy back against 3 separate pins. And you can sort of see that right here. So here's the 3 pins, the part will go in here. This isn't to scale. This is enlarged just to make it easier to read the drawing. But this part will go here with the flat part actually pointing back. This guy will sit right here. And then the rotary, the eccentric cam right here will push against this guy and push this into the part, which will push it into the 3 pins. And I've never done anything like this, so I'm kind of excited about it. Also, the reason why this part is so oddly shaped is there's going to be a spring attached to this, which the point of was so that when the rotary cam is disengaged and loose, this part will push away from the pocket so that the next part can be set in easily. So that's the whole idea. Originally I was going to machine these out of Delrin, which I got right here, but then I said, you know what, why do that when I can just as easily 3D print it and I can actually make it a lot fancier. So you notice the spring pocket there to catch this clip is really cool. And that should hold it nicely without falling out. And this is the rotating point right here. Just going to start by flattening one side of this guy real quick. Going to face the one side to make it flat. So I'm just going to do a 5,000th pass here. And I also want to try isopropyl alcohol as a cutting fluid just to see how it does. We're going to flip this guy around. So if I wanted 1 inch for the top, that would leave me 2 inches for the post, which is more than enough. We're going to be taking off a ton of material. I got to take off some of the material on the back here because it is kind of screwed up. Had a big drill bit cut into it at some point in time. Okay, we're going to call that Z knot. See how we do with 100 thousandths passes, and I'm going to use this guy as cutting fluid here. Doing 100 thousandths passes. This insert will do, I think, up to 150 thousandths, but starts to have some issues, so we'll just keep the feed rate up and go with that. Face inside out. Beautiful finish right there. Okay. Gotta use the back of the insert over here because it's so close to the chuck. Oh, too close to the chuck. That was not good. Can't reach it. I decided I flipped the part around. I decided I'm gonna mark the center of this guy. It might help me find the center later on, so it won't hurt anything as far as the part working, but it will help me find the center. And I know that I left it a little over an inch, but this distance matters not at all. 1.1 inches, as a matter of fact. That'll be fine. Next up, we're going to head over, drill and ream for the dowel pins here. And the two screws that will hold, one is this piece, that is the spring-loaded pressure plate, I call it, and then the eccentric cam. The eccentric cam is going to be a 1032, which is what these are. This is an 832, and I am still waiting for those parts from McMaster. They are late, which is something McMaster almost never is. I might have to make my own socket head shoulder screws. By the way, they also make them in plastic, which I bought just because I wanted to see what they were like. There's actually not going to be any force on this guy, so I could potentially turn one of these down to work with this guy, because they're very, very smooth on the outside. I think they're nylon or Delrin, I don't know. Anyways, they were fairly inexpensive, especially relative to these guys, although the precision's nowhere near as good. These are 3/8 and 1/2 inch shoulders. This is 1/2 inch. So originally I was thinking about countersinking these, but I don't think I'm going to. Also, my original thought before using the eccentric cam idea was to use these different push toggles. And I've got 4 different types here, and I think this one might have worked. I almost used this one, but the handle would stick out so far. That's why I didn't ultimately go with it, but it probably would have been fine, and the handle I'm making for the eccentric cam probably will stick out equally far. So we're going to mount this guy in here, sitting on a parallel and an angle block. That's a low profile one. That way it touches at 3 points rather than just 2. So one line on each side of the angle block and another line on the rear jaw of the chuck. One of these days I'm going to make a angle block with a shallower angle out of hardened steel. I still need to do that. That would be really handy and would probably work better for these larger diameter parts. I need to find the center of this, and that's why I put the center drill hole here, so that I could use this 1/2 inch pointer essentially to roughly find the center, and then we'll see how close we are to the actual center after. So rather than using the Blake indicator, this time I am using my Michutoyo, and this is within 1/2 thou all the way around. I know you can't see that, like 1/2 thou, less than 1/2 thou now. So a couple tenths, and I think I'm going to call that good. All right, so we're going to drill the first hole. We're going to spot drill it first. All right, so here's the fit. I originally was going to make it a press fit, but instead it's a piston fit. And I decided to do that because I wasn't able to drill all the way through the part like I wanted to. For these two here, they'll be too close to the middle. They'll actually be in the shaft. So what I wanted to do originally was make it a press fit, but put a hole through the other side so I could punch these pins out if I needed to replace them or, you know, change them in some way. So instead, I just made it for a sliding fit and sort of a piston fit, which is really good. All right, let's do a test fit real quick. Just pop these pins in. I think I might want this pin to be a little bit taller to meet with the top of this, but it's a pretty good fit. If this pushes in, I think it'll hold it in place. There is a little slop side to side, but that's because this part is several thousandths below nominal. So they gave me the nominal measurement, and it's like 4 thousandths under. I didn't want this to be super tight, too tight. So, yeah, if this thing is not centered, hopefully, if you push on this, it'll find center. This, geez. Maybe this is not ideal only because this can rotate a little bit. And if you do that, that's shifting your center position. So if the part goes in straight, then this will be right on center. And if you push it in straight, it wants to go. I think that should be right on center. And we could use an indicator. So let me drill the other holes and see. I mean, maybe this is not the ideal solution, but even if I did a pocket with this or I made some flat pieces, this still would have to have an extra bit of clearance for the, you know, the part differences, you know, differences between parts. And I didn't get a spec on the part itself as far as what clearances should be. I mean, as far as what tolerances they expect. So I don't know. I gave it 0.002 is all I gave it. Let's see about a taller pin, see what happens. This is a much taller pin, obviously. But that'll touch in 2 points. Yeah, it still rotates. Same amount, so that's not an improvement. Here's the tap hole for the eccentric cam. So the pivot's going to go right there. And so I need to stretch the spring out. All this does is keep this out of the way of the part when you've got the cam released, which just makes it, it's a convenience feature. That's all it is. Got the scrap piece of easy machining stainless. The diameter is supposed to be 0.750 roughly. So I should face this. Here's my cam. I left 5,000 of material on the top part here just to clean off. All right, so we have this part here clamped again. We're within about 1/2 thou of dead center. And we want our whole 125 thousandths off of center to one side. Doesn't really matter. So we're just gonna pick one at random and drill it. Then we're looking for the shoulder bolts are 0.247. And so this is 0.249. This is 2 thousandths over. So we'll try and ream it 0.249, see how that works out. I think they're expecting 0.250, like 1/4 inch, but that seems like too much slop to me. So we'll try this, see how it works. All right, so we're gonna drill a through hole 1/8 of an inch north of center, dead center. And that will give us an eccentricity of a total of 1/4 inch, which I don't need that much, but it will make 1/2 a cycle tighten this guy up, which is what I do want. All right, so we drilled and reamed for a couple thousandths over, and that is a fantastic fit. There is just the slightest wiggle. That's better than just drilling a 1/4 inch hole with, you know, there'd probably be 1,000th or 2 over. This is a really nice fit. That'll make a good pivot. All right, so I need to take some material off the top here just to clean this up. Okay. Yep, that's 499 right on the money. Well, 2/10 under, so 0.4988. And I think we're good. All right, so we're gonna drill for the handle. And I actually need a flat, so we're gonna start with a 1/4 inch end mill. Here's the eccentric cam. We just need to make the handle for it. All right, let's see if we can assemble this guy and see if it works. I made this handle. This is just some 1/4 inch 01 I had, and I put some 1032 threads on it to match this, and it's counter drilled or bored for the shaft so it doesn't show up. Let's see. Lost my track of where I was. Okay, so this guy is going to go here. I'm still missing one of the screws, so I'm going to have to fudge something. McMaster Carr is going to deliver it to me tomorrow. By the way, I shout out to McMaster Carr, which is where all these parts came from. I placed 2 orders on a Sunday. They said they'd be here by Tuesday. They typically take 1 day. Sometimes you can even get them same day. So they shipped them both packages on Monday. And on Tuesday, I got one of them. The other one is lost by UPS. So I called them today and asked them if they had a better, insight to what's going on with UPS, because I thought maybe they had a better interface than I do. And they said, oh, you didn't get your package? Oh, I see that. Oh, that's not right. We're going to counter ship you one next day, morning delivery. And I said, no. I just wanted to see if I could find out where the package was. They said, no, we want you to have your parts. It's a small order. It was an $80 order. And they're shipping to me next day. McMaster Car cannot be beat for customer service. Absolutely amazing, top-notch customer service every time I've ever had to deal with them, which is like 4 or 5 times. Okay, where were we? All right, so here's my eccentric cam. So you can see here it's loose, getting tighter. So then this guy is just going to be the 832 that sits here. You can tell it's not the right diameter, but we're going to let it sit there and see if that works. This spring goes here. I should probably put these in ahead of time. So this part will have a shoulder bolt in place, hopefully by tomorrow. Well, they promised by tomorrow, so I believe them. So this spring, you can see the point of it now. The whole job of the spring is just to keep this part, when I release this, away from this intersection. So here's my part. I drop it in. And I think my cam is not gradual enough because it's not wedging. I think it's too dramatic. I think I might have to remake this piece. But there's the idea. You can see that this releases the part and it self-aligns. All right, so I'm still waiting for the McMaster part. So I decided just to make a 207 thousandths shaft here that would fit right down the center of this. These will be really easy to swap out if they get kind of damaged. They are 100% infill, but they still might crush out over time. Hopefully not. So the previous one I was wrong. When I said this one was 125 thousandths, it actually was 62 thousandths offset. This one is 12 thousandths offset. So very mild offset, and I made it larger diameter, so I had to move the hole this way as well. But that allows it to be much tighter and much easier. So this thing sits in here like this, locks in really nice and tight. They got to make sure to push down when they're putting it in. I was thinking about making like this part sloped so it would push the part down, but if they're careful, this should hold pretty well and hold it tight. It's pretty darn tight in there, and these pieces are easily replaceable and you can always print more. And the part comes out pretty easily, which is good. So the next one can just go in and lock it down, and we are good. I think that's it. I think we're good to go. So we'll find out what the vendor thinks about it. Larger diameter here with a smaller offset means that the slope, as this thing starts to tighten, is much narrower, which means it's easier to grab, and it just seems to work a lot better. So again, about 12 thousandths instead of 62.5 thousandths, and 1 inch diameter instead of 3/4 inch diameter. And I made this one out of brass because that's what I had. And you'll also notice I cut a flat here because reorienting this, I never set a 0 on this thing, and it almost hosed me. It took me a long time to get this guy clocked in again. It was actually really difficult. So that was another lesson learned. That's it. Thanks for watching. Hope you find it useful. Hope to see you next time.